Algebra II 7.3a, find roots of quotients and theorem. Okay, we're moving along in Chapter 7 here, and all the links to the previous videos for Chapter 7 are in this video's description. So if you become lost or confused during this video, go back and watch some of those, okay, if not all of them. So we have the square root of the quotient of 16 and 9. We can break it into two different radical signs for the numerator and denominator. We get the square root of 16 divided by the square root of 9. Square root of 16 is a 4, square root of 9 is a 3. We get 4/3. We can do the same thing for cube roots. The cube root of the quotient of 27 and 8 would be the cube root of 27 divided by the cube root of 8. Cube root of 27 is a 3. 3 times 3 times 3 is 27. And the cube root of 8 is 2 times 2 times 2. That equals 8. And we get 3/2. So here's our theorem. For any natural number index k and any real numbers a and b, as long as that b is not a 0, where the kth root of a and the kth root of b are real numbers, we can take the kth root of the quotient of a and b and split it into the kth root of a divided by the kth root of b. And from this theorem, we have a rule, finding kth roots. To find the kth root of a quotient, find the kth roots of the numerator and denominator separately. And we can simplify by finding roots of the numerator and denominator. We've got the cube root of the quotient of 27 and 125. We split them into their own radical signs for the numerator and denominator. We get the cube root of 27 divided by the cube root of 125. Cube root of 27 is a 3. Cube root of 125 is a 5. We get 3/5. And we did it. See? It's not that hard, right? So just remember, because we're going to be doing this in a couple seconds, when simplifying an even root to an odd exponent, we use absolute value bars on variables. So if we've got the fourth root of 81x to the fourth, we can remove this radical sign and that 4 exponent because it's to the fourth root, and we get a 3x. But because we went from an even root to an odd power, an odd exponent, because that's x to the first power, right? We just don't have to write the 1. Then it goes in absolute value bars, okay? Unless we know it's a non-negative, all right? So take a look at this one. So we know when we see this square root symbol that there's actually a little 2 root here, okay? So that's an even root. So we've got the square root of the quotient of 25 and y squared. We can break it up into two separate ones for numerator and denominator. Square root of 25 is a 5. And the square root of y squared, because that's got a little 2 exponent, we can take away this radical sign and just put a y. That's y to the first power. So we went from an even root to an odd exponent because it's y to the first, right? 1 is an odd number. So we're going to use absolute value bars around that y, okay? Let's try this again. We've got the square root of the quotient of 4a cubed and b to the fourth. We can split them into their own radical signs, and when we factor this out, we get 2 squared times a squared times a. Trying to find some perfect squares here that we can factor out, and this b square root of b to the fourth becomes the square root of b squared squared. See? So now we take out any perfect squares, so that 2 and that a, because they have little 2 exponents and it's under a square root with a 2 here, invisible 2, becomes just a 2a. And because this a went from an even root to an odd power, an odd exponent, we're going to put absolute value bars around it, okay? And this little a here is going to stay underneath the square root sign because he's not a perfect square, okay? This b squared squared, we can remove this radical sign and one of these little 2's. We do the one on the outside, and we end up with just b squared. So we went from an even root to an odd exponent, and we used absolute value bars around that a. Okay? All right, let's take a look at this one. We've got the, let me do my focus here. We've got the cube root of the quotient of 27y to the fifth and 343x cubed. We split them into their own radical signs for numerator and denominator. And 27 can be broken into a 3 times 3 times 3, can't it? Because 3 cubed is a 27. And this y to the fifth, we can pull out a perfect cube of y to the third, but then there's a y to the second left over, isn't there? And for this cube root of 343x cubed, we're just going to leave it as it is right now, but we're going to pull it apart in a second. I just wanted to show you the numerator being broken apart, okay? So we can split this into two separate factors, okay? So we've got the cube root of 27y cubed and multiplied by the cube root of y squared. So we know that 27 is a 3 cubed, isn't it? So we can write it like that. And then we've got the y cubed here times the cube root of y squared. We remove those perfect cubes, and this 3 and that y can go in front of the radical sign. We remove their little exponents and this radical sign and that little 3 root and put them up here. And because that's not a perfect cube, he's going to stay underneath the radical sign, okay? So this cube root of 343x cubed, remember, that's going to be a 7 cubed. We've got a little 3 exponent here, and we've got our 3 root here, so we can remove the radical sign and that little 3 for the 7 and the x. They both have a little 3 exponent. We pull all that off, and we get a 7x, see? All right, let's take a look at this one. And we've got the cube root of the quotient of 64x to the 7th and 216y to the 6th. Now, I wanted to show you this one because you're going to come across stuff like this, and I wanted to explain what's going on because you might get confused when you get down it. You say, wait, I don't understand why, I got it marked wrong when you left it like this. It's because we didn't completely simplify it, okay? So we split this into their own radical signs, like we've been doing, and this 64 x to the 7th can be broken into an x squared to the 3rd power, because 2 times 3 is 6, and then this little x makes the 7th one, okay? And 4 times 4 times 4 equals 64, so we know that's going to be a 4 cubed. 216 is 6 times 6 times 6, so that's going to be a 6 cubed. We've got x squared to the 3rd power and y squared to the 3rd power right on top of each other, and we've got our little x here. So we remove all the perfect cubes, okay? So we're going to remove all these perfect cubes. So we're going to remove this 3, that 3, and that radical sign. And we're going to be left with the 4x squared right here. This is not a perfect cube, so he's going to stay underneath that radical sign with his root. And we've got a perfect cube here and a perfect cube here. So we can remove this radical sign and that root 3, and we get a 6 and a y squared down here. But we're not done because we know 4 6 can be simplified to 2/3. So if you leave it like this, you could get it marked wrong. Even though you did everything correctly, this is not simplified. 4 6 can be simplified to 2/3, can't it? So we're going to get a 2x squared cube root of x divided by 3y squared. See? So you have to keep going if you see this. If you see 5/15, you know it's 1/3, right? So just keep going until you know it's simplified, all right? Our next video is 7.3b. We're going to talk about how to divide radical expressions. I'm going to add this video to the Algebra 2 playlist for studying. From last year in Algebra 1, Chapter 11, we did 11.3, 11.4, and 11.5, and we talked about this, okay? So you can watch those videos. Those links will be in this description. So if this one is too confusing for you, maybe you can watch the Algebra 1 videos and say, oh, okay, now I get it, and watch this one again, and you'll completely have it. I'm also going to put a link to 5.6, which was our big review video on factoring, in case you forgot how to factor. That might help you to review that real quick. And all those Chapter 7 previous videos that we just did, okay, to help you out. So there's going to be an awful lot of links in this description, but I do that to help you so that you can just breeze through them and click on the ones you want to watch without having to search all over YouTube for them, okay? Or through all my playlists. You can just click on them, all right? So keep trying. I'm proud of you. I really think you can do this, okay? I'll see you next video. Bye.